Chapter 3, Decisions, Part 1. Our goals for this chapter are to learn how to implement decisions using the if statement, to compare integers, floating point numbers, and strings, to write statements using the Boolean data type, and to develop strategies for testing your programs, and finally to validate user input. The if statement gives us the ability to make decisions based on input or certain circumstances. For example, this chapter uses an elevator example, and on most high-rise elevators there is not a 13th floor. So the elevator needs to be programmed to skip the 13th floor. The 14th floor, as shown on the user display, is in actuality the 13th floor of the building. So every floor above 12 is really floor minus 1. And there are two key words that we use in the if statement, and they are if and else. Every if statement does not require an else. However, every else must have an if, as we'll see in just a minute. The if statement allows a program to carry out different actions depending on the nature of the data to be processed. So here's a flowchart showing that elevator example. We're using the diamond shape for a decision. If the floor is greater than 13, if that's true, then the actual floor is the floor minus 1. If that's false, then the actual floor is the same as the floor. And notice the if statement to the right of the flowchart. Int actual floor is an integer variable. Floor is also an integer variable, but we don't see that declaration shown here. If floor is greater than 13, actual floor equals floor minus 1. Else, actual floor equals floor. So notice how we've lined up the if and the else, and also notice how the statements following the if, the statements we want to do if that Boolean expression is true, are contained in braces. These are optional if there's only one statement, but it's good programming practice to use them anyway for those times when you have more than one statement. So let's assume that there is nothing different that we're going to do as far as a false branch, so we don't need an else. If the floor is greater than 13, we set actual floor equal to actual floor minus minus, so we don't need an else. Notice that we've initialized actual floor to floor before we encounter the if statement. This is a little bit more simple than the previous example, and no else is required. So the syntax of the if statement is as follows. The keyword if, and note that it's all lowercase, all keywords are all lowercase, followed by some Boolean expression that's in parentheses. And a Boolean expression is one that results in a true or a false answer. If that condition is true, then the statements that appear in the code block following the if statement are executed, as shown here in braces. The other type of if statement is if condition. Now if that condition is true, statements 1 will be executed. Else, that means that condition was not true and we have something else that we want to do. In that case, this statements 2 are executed. So a Boolean expression is formed either with Boolean variables or with some operation that's going to result in a true or a false. Here we're using relational operators. There are 6 relational operators in Java. They are the double equal sign next to each other. That stands for equal to. That's testing for equivalence. There's the not equal to, the exclamation point in Java. We read not equal to. Less than or equal to, greater than, and greater than or equal to. The most common mistake I see my students make is that they flip the less than or equal to, they flip it around and make it equal to or less than. Similarly, with greater than or equal to, they make it equal to or greater than. That's not a known operator in Java, so just be sure that you are using one of the 6 relational operators provided. Further notice that there is no semicolon at the end of the Boolean expression following the keyword if. That semicolon would terminate the if statement, so it's syntactically correct but logically wrong. Here's an example of an elevator simulation program. I have provided a walkthrough of this program inside the course document, and you can feel free to run that when you're finished with the lectures. I encourage you to practice with this by typing up the code, because if you make a mistake, you'll have the original source here to check your work, and it's always a good idea to get in the habit of typing up codes so you can see how it works. Tips on braces. I strongly encourage you to line up your braces so the open brace occurs underneath the I in if, and the closed brace lines up in the same column following the code block. Some programmers prefer to leave the open brace at the end of the line that starts the code block, as in if floor greater than 13, open brace, all in one line. And that actually is the default from NetBeans. But for beginning programmers, I think that this style is difficult to follow. It's difficult to make sure that your open brace has a corresponding closed brace. So I prefer that you use the style shown on the left rather than the style shown on the right. NetBeans makes it pretty easy to indent code blocks as long as you use the tab key to indent. If you use the space bar, NetBeans is not as good at helping you line things up. Another cool thing about NetBeans is that it provides vertical gray bars that you can use as a guide to line up your code. So notice in this example that it's showing each successive indentation level. Our class is at indentation level 0. Our main method is at indentation level 1. Our if statement is at indentation level 2. And the body of the if statement at indentation level number 3. Those levels are unimportant, but notice that inside every open brace and closed brace, we indent to the next level.